Hi, this is my fourth experiment, base conversions. The first question is binary to decimal, octal and hexadecimal conversions. First, I'm getting binary numbers and reading it in num. Then my three options are binary to decimal, binary to octal and binary to hexadecimal. I'm reading the operations in OP. Then I'm having three cases. Case one is binary to decimal operation. First, I'm initializing the power equal to 1, and while the num is not equal to 0, it will do the operation, uh, it will calculate the operation REM, TMP, decimal, power, and num. In REM, dollar num mod 10, uh, the entered number mod 10, and it will store it in REM. In temp, the calculated value REM into the power value, and for decimal, the decimal value plus the temp value. Then for power, the obtained power value into 2, and num is equal to dollar num by 10. Mm. And it will print the decimal value here. The entered binary value will be converted into decimal and it will be printed here. Then um, next one is binary to octal conversion. This is same as the operation done before, and the one thing we have to give is, while decimal is not equal to 0, the operation is decimal mod 8. Because of the finding octal value, the decimal value should be mod by 8, and we should multiply the octal value and the remainder value. Then decimal value is equal to decimal by 8, and it will print the octal value. Next one is binary to hexadecimal. First, power is, we are initializing the power is equal to 1. Then while num is not equal to 0, it will do the operation in the case 1, and if while decimal is not equal to 0, REM is equal to decimal mod 16. Uh, like same as octal, we have mod the value by 16, and we're printing the hexadecimal value here. Hmm. Uh, Here I'm entering a binary value 0101, and the options are binary to decimal, binary to octal, and binary to hexadecimal. The decimal value of the binary number 0101 is 5. Then 0110. I'm converting the binary value to hexadecimal. The hexadecimal value here is 6. Then A plus 2x. This is octal to decimal, binary, and hexadecimal conversion. Uh, I've entered a octal value. I'm reading it in num. Then three options are octal to decimal, octal to binary, octal to hexadecimal. I'm entering the operation to be performed. Then in the first case, octal to decimal conversion, I'm initializing the power is equal to 1, and while num is not equal to 0, the operation is rem num, the entered value mod 10, and the value obtained before into power, and the is, decimal is calculated with the decimal value into 10, and for power value, the power value obtained into 8, That's all. It will print the decimal value here. And for octal to binary conversion, as usual, the same steps done before. Here, after checking these conditions, while a decimal is not equal to 0, we have to mod the decimal value by 2 and multiply the binary value into the rem value and divide the decimal value by 2 so that we can obtain the binary value. And for decimal, octal to decimal, mm, uh, I have been initialized power is equal to 1 while num is not equal to 0. The same steps to be done, and while decimal is not equal to 0, decimal value is mod by 16 and the hexadecimal value is printed. The decimal value is divided by 16. I'm compiling here the program. The octal values, I'm converting the octal value to binary. The value is 1110. Then this is decimal to binary, octal and hexadecimal conversion. In the first case, for obtaining the binary value, uh, I'm doing three operations: mod, divide, and multiply. Mm, the value entered by the user is first mod by 2 and say I'm saving it in rem. And for binary value, I'm multiplying the rem and binary value, the value obtained, and in num, dollar $num by 2. Then I'm printing the binary value in decimal to octal conversion. While num is not equal to 0, the same operation done before is repeated. But the difference is here we are dividing and modding the value by 2. Because of all octal, here we are modding the value by 8. Then for decimal to hexadecimal conversion, while num is not equal to 0, rem value is calculated by modding the num value into 16. This is hexadecimal to decimal binary and octal conversions. As usual, I'm getting a hexadecimal number and reading it in num. Then three options are printed. Then I'm reading the operations in OP, and the three cases are echo hexadecimal to decimal. The decimal value is, this is the predefined function I base equal to 16. If I gave the decimal value equal to I base equal to 16, it will calculate the decimal value and print the decimal value. Then next, for hexadecimal to binary conversion, the predefined function is I base 16 and O base 2. It will calculate the binary value from hexadecimal and print the binary value here. And for hexadecimal to octal, the predefined function is I base 16, O base 8. For octal, the O base is 8 and it will print the octal value here. And my output is SS. Hexadecimal number is 32. the value is converted into decimal value. Then this is the octal value of the entered number. That's all about the base conversion program. Thank you.